All right, well, we skipped forward to this one. Thanks, everybody, and thank you for the invitation to join in this presentation. Chris, I really appreciate the opportunity to be here. And our company, Green Edge Computing Corporation, GECCO, we call it GECCO for short. That's why we have the logo with the gecko in the corner. And what I wanted to do is talk about some of the hardware. So it was very interesting to see Lars's demonstration of CODESYS running, and then Red Hat is kind of one step outside of that. And then Nicholas is giving some practical applications and real life scenario for the use of the CODESYS software running in the virtual PLCs. So I'm one step above that, and that's the conversation around how do we bring all of this into a real server environment. Nicholas had a good sketch of the server sitting on the side there, and that's what we want to talk about is a unified platform, an advanced compute platform that will run all of the software in these edge applications. Automation is generally in an edge environment. When we say edge, we mean not in the cloud. It is, as we've all seen, with the advent of smartphones and all of the technologies, there's a lot of cloud-enabled technologies, but that doesn't necessarily always go and fit well in the environments where automation is required. And those edge environments can be very challenging. We've got multiple vendors and multiple protocols, some of which already were presented and talked about. There's a trend not only for virtual PLCs, virtual machines, centrally managing a lot of technologies, not necessarily centrally in a cloud location, but centrally within the company or within the factory environment. There's almost daily some new technology and some new algorithms being introduced for the Internet of Things, for AI, for wireless communications. And the technology the platform to embrace these new technologies and new algorithms is quite keenly required right now. And you've all familiar with the OT, IT bridge requirements, so the operational technologies and information technologies. An interesting aspect of that, in my experience, is that they tend to be two totally different groups of people, and often in the factory environment where the OT systems reign supreme, isn't necessarily a friendly environment for the information technology systems, the corporate IT people that are trying to run networks and cloud and data center environments. So the ability to converge and bridge those systems is pretty important. And one of the key aspects of this conversation now is about the harsh and exposed environments that you will experience on the edge. So let me talk about that one for just a moment. The problem in these edge environments is that often the technology that you need to run these advanced algorithms and software require IT equipment that simply isn't suitable for those environments. Either they're too big or in some cases too heavy, and often require some dedicated power and dedicated cooling systems. And the environmental challenges of the areas where that equipment needs to be installed makes it a difficult match because of vibration and dust and humidity. Even the sprinklers going on, sprinklers in a computer room are not a welcome mix. Lastly, there's a concern about the total cost of ownership of these IT systems. They tend to run on a relatively short lifetime. They're frequently being upgraded and modified, and that can really add to the overall cost of running these systems. And if you have a large facility or numerous facilities, then managing these IT systems at scale, when you might have dozens, hundreds, or even thousands of edge nodes, can be very, very challenging. So what do we do about it? Typically, the conventional blade or IT rack-mounted equipment which includes your servers and your switch and your data storage capability and all the security infrastructure, would have to go into a computer room of some sort with appropriate air conditioning and a power system. That can be very costly. That's up to about $1,000 a square foot. And many existing factory facilities or manufacturing facilities, edge facilities, simply don't have the space for it, or it's very costly to do it. So the second choice then is to buy some kind of a rack or enclosure, which surprisingly ends up in places where forklifts might run into them, or they get in the way of warehousing equipment and so on. So that's not really an ideal solution. And the worst of all, but perhaps the most common one of all, is that the IT systems end up in the janitor's closet somewhere on a wooden shelf, and that's not secure for business critical systems. So I think probably everybody's seen some of these. If you're lucky, it's a little less extreme as putting it in a janitor's closet, but it's surprisingly frequent in some manager's office, etc. How have we addressed this? We've developed the EdgePod. The GECCO EdgePod is quite a bit smaller. You can see by the size of the hand here that it's about the size of a large shoebox or hiking boots, perhaps would be the appropriate size of box. But there's room in there for a number of servers, 4 servers and a switch and some storage. So we're converging everything that you need in these edge computing environments into one small space, into one small sealed and secured location. It's at least 90% smaller and lighter than what you would get if you're using conventional servers. The operating cost as a result is much lower. There's less power required. There's no specified or dedicated cooling required to it. It's a relatively low heat generating but high processing capability environment. It's ruggedized so that it'll operate in these dirty and dusty environments. And for those companies that have an environmental target, ESG goals, the reduction of energy consumption can make a dramatic impact on their overall targets for reducing greenhouse gas emissions. Inside this EdgePod, there can be up to 4 EdgeCard servers. These servers will fit in the palm of your hand. That is not a hard drive that you're looking at there. That is a server that is either an Intel Xeon or an AMD EPYC multi-core server. There can be 8, 12, 16 cores. We're using low-powered versions of those servers, and those are the ones that are there. And when you have 4 of these servers, that gives you up to 4 times 16 cores, so 64 cores or 128 virtual CPUs that you can use for the containers and the virtual machines that Dave was talking about, for example, with the implementation of Red Hat. We are an Intel Gold partner, and we're working closely with them as well, so that the kind of unified advanced compute platform that Dave was talking about can be implemented using this hardware. A very important aspect of this is that it's got no moving parts. There is no fan in here. There's no blowing air. Everything is passively cooled from the server to the EdgePod itself. And one last comment in here is for reliability and connectivity. We've evolved this using some standardized interface technology that comes out of the defense world. So we have a very high reliability, sort of military grade, defense grade technology that we're bringing into the commercial and industrial world. This makes the EdgePod an ideal platform for the virtual PLCs that we've been talking about today. Whatever protocols that are being used, whether it's Profinet or EtherCAT, as have been discussed a couple of times, running over a combined channel, a combined Ethernet cable, different protocols, different VLANs, running into the different application scenarios, the different control scenarios that we have. This is obviously a very simplistic diagram, but we did with Lars, in fact, did a very nice job of demonstrating this. And I hope, Chris, you don't mind that I'm showing a picture with your smiling face on it, but this was at Automate in Chicago earlier this year, where you can see that we have the EdgePod running the CODESYS virtual PLC and a number of the components, the devices on the right there. You see myself in the middle. Jeff is standing next to me, and then Chris and Mark. And we were very delighted to be part of that presentation there. So this is no surprise, but what we're really doing is we're quite simply leaving the field device in place where the input and the output capability that actually performs the control scenario, and we're moving the programmable logic from the CODESYS software right over into the EdgePod. And if you do that multiple times, we end up with a unified platform for these virtual PLCs. We can use multiple protocols over a single network. We can support virtual machines and containers with those multiple virtual CPUs that are available in there. We can provide advanced on-premise cybersecurity. That hasn't really been discussed yet today, but you do need quite significant processing capabilities if you want to maintain a connection between your automation environment and the IT world. So giving a platform that anchors that security capability is very important. It is open and scalable, and supports the whole constant innovation, constant deployment for remote management and audits and understanding who's doing what and when and where. And perhaps equally important is that this capability then provides a platform for a lot of other advanced technologies and software, whether it's artificial intelligence type algorithms running on video streams, or maybe it's completely remote information inputs like understanding weather patterns or other external inputs that might influence the production or the automation processes that wouldn't traditionally be supported simply within a PLC. We can now integrate those other data sources and into the algorithms, and also take those results from the virtual PLCs and use those to inform decisions that are outside of the PLC environment. Just a few of the key features of this EdgePod. I mentioned it once. I think this is really important, that we're able to provide a passive cooling without using any fans. This really improves the longevity. We can provide a 5-year warranty, and we have a 10-year design life, and expect the EdgePod to survive much more than 10 years, but we have to draw the line somewhere. So passive cooling and no fans is hugely important in environments where there's dust and dirt and vapors and liquids and so on floating around. Keeping everything pluggable is extremely helpful in terms of reducing the complexity of maintenance and upgrades, so that the IT skill set of somebody in the field doesn't have to be all that high, and you open the door, plug in the new server, swap it out, and shut the door. The door itself is controlled with a digital key, so that you cannot bypass it. It's out of band communications security access control system, and that provides a full audit trail so that you know who accessed the EdgePod and what they did, how they left it. Connectivity at 10 gigabits to the pod itself and between the servers within the pod. That's necessary to ensure a good high-speed throughput of all the information that we're processing. An integrated power supply. This thing will run off of DC, so you can use whatever sources. This has been useful for us in discussions with companies that have remote automation systems out in locations where perhaps they only have for example, a solar or battery backed up system. So low power requirement that runs off DC makes it very convenient for that. There is an opportunity within the pod to expand with AI GPU accelerators, so that you can do some of the video stream analytics off of the CPU and relieve some of the CPU pressure. And we've demonstrated how that works. We can expand the memory. There's opportunities for different types of communication and extending the I/O. And we're working on a shared storage facility within these EdgePods, so that we anticipate going up to 64 terabytes of shared storage. And somehow I managed to skip the fact that, oh, here it is, that within the Edge card itself, there's also up to 2 8 TB SSDs could go in there. So there's opportunity for 16 terabytes on each of the of extended drives, basically solid state drives on each of the servers, as well as 64 gig of RAM and space for the GPU AI accelerators in there as well. I mentioned the connectivity provided by defense industry technologies. So we've adopted the VPX, if you're not familiar with that. That's an evolution of connectorized interface standard. That makes all of these Edge cards pluggable into the EdgePod. And it's impossible to plug it in wrong, and you don't have wiring errors and COM errors as a result. The power and the communications and the interfaces between all of those servers within the pod and then between pods is very, very reliable as a result. This is designed for high vibration shock environments, extended temperature range, and so on. So we have a very reliable computing platform as a result. We've also provided these front interfaces so that you can do some standalone operation if you need to do some benchmark preparation, configuration, testing, or validation before it gets deployed out into the EdgePod. The next few slides are just a few examples of the sorts of areas where we're seeing interest for the EdgePod. A lot of resource industries, many different types of resource industries, whether it's mining, oil and gas, exploration, refineries, where some of these advanced requirements like video analytics and detecting anomalies on digging equipment, losing the tooth, and detecting fires and heat, hot spots in equipment, and worrying about health and safety of the workers and the environment. Those are all very challenging situations where the conventional PLCs need to be augmented with more complex data sources. And this unified platform gives them the ability to do that. Autonomous vehicles, private wireless. These are all very interesting challenges for automation in the modern environment that we're trying to address. In the manufacturing field that perhaps many of the people on this call are familiar with, there's also challenges for video analytics and identifying some process oversight you're familiar with, is the label on straight, but it gets more complicated than that. Nowadays, there's a desire to do maybe face detection and perimeter security identification and block fire exits and all these sorts of things as well. Condition-based maintenance is increasingly interesting as well. And that is a classic example of multiple inputs from multiple systems that are coming together and need some decision-making based on that. And then in the sort of smart infrastructure, smart cities, transit systems, transportation systems, that's another good example. This isn't meant to be a complete list of where the application is. The edge is huge, but these are some very interesting challenges that we're able to address with a unified system, for example, trackside automation, control, obstruction identification, and so on. EdgePods basically will go anywhere. All of those locations that you see in this little dial, and many, many others. It's resilient, it's rugged, it's designed for the edge. This is the focus of what GECCO does, is provide these multi-server, highly capable, industrialized, ruggedized PCs, server level PCs that will let you run virtual PLCs on up to 128 virtual CPUs. That would be 4 servers, each of them 16 cores, multi-threaded. So now you've got 128 vCPUs that you could run in there. Advanced software for all your artificial intelligence, augmented reality, virtual reality, and so on. Those are all supported in this kind of environment, using the Red Hat compute environment, doing the kinds of things that Nicholas was talking about, and implementing VLCs the way that Lars was talking about. That second to last point, I didn't really touch on it, but I think it's maybe important to just call out. There isn't a camera mounted on the door, so that we can provide over-the-shoulder remote support. So if you have somebody in the field that is being asked to swap out a server or make some modifications, you can actually remotely help them out. And that can be, that's one way that we've thought of to reduce the total cost of ownership by reducing the cost of service calls. So that's all I have to say for now. I wanted to thank you for your time for listening.